Thank you, Michelle. Yes, my name is Jessica Kerr, better known as Jessitron, and I am excited to talk about let's let go of velocity and think instead about acceleration. Because I was a physics major, that's like my college degree, and I don't remember much from it, but I really remember this stuff. Along the way, in this presentation, we will answer the important question. What I really want to get to is how do we get better at our jobs? Hint, it's not just going faster. Along the way, we'll answer these other compelling questions, enduring questions in software, such as what is done and which programming language is the best? And the one that eats me at night, why is this so hard? Because I've been developing for 18 years now, and it has not gotten easier. It has only gotten harder and harder and more interesting. And I used to think, maybe it's me, maybe I'm getting old. I did turn 40 this year. But the more I think about it, the more I think it's really not me. And there's just a lot to this job. And if we think about it as complexly, if we let it be as complex as it is, it makes sense that it's hard. And we can get better at it. So if you have a worksheet, you might consider a study in velocity and acceleration. So the first activity is to draw a line with constant positive velocity, something like that. And this graph is happiness over time, where the happy face represents like the value of our software to our users. And time represents how much time we've spent working on it. And this is what managers want this graph to look at. Everyone loves this graph because it's nice and steady and predictable, and it goes up and to the right, as all good graphs should. This graph is complete crap, of course. Nothing on this graph is real. But we wish it was. And if it were, its velocity would be a constant, because velocity is change over time. So the d-happy dt here is approximately 1. That would be great if this was how it worked, and we would find everything very easy to plan. But software is not that simple. So if I draw my estimate of really how software value changes over time in a given project, I'd say, well, first you get to move really fast and you're all excited because you're getting stuff done because there's greenfield and there's not a lot of stuff to do. And then it gets harder. And then, oh, bug in production. And then we fix it. And then at some point we stop working on it, right? We deliver it and then we set it on the back burner and we go work on some new shiny thing. And people like to think that the value now remains constant. Ha-ha. No, it does not. Because the environment changes, libraries change, the users change. The definition of value is not the same all the time. And pretty soon, someone else has come out with some other software that's better than this. But no, you must continue using this. It's a capital investment. We spent money on this. You will continue using this, even though it hasn't changed in 3 years, and other things are better. And at this point, you are suffering from zombie software. So your exercise next is to draw a zombie that's better than that one. This should not be a challenge. Right. So really, not only is the value over time not constant, but it really does turn negative if we're not constantly working and paying attention to the software. So that's the first thing that's crap. But everything else about this crap is also crap. For instance, time. Why do we measure time as an input to software development? Because we can. Because we have clocks, and we can get beautiful, precise numbers out of them that we really like. Turns out that in complex systems, measuring anything precisely is bad, and don't go any more precise than t-shirt sizes. But separately from that, I don't think time is an accurate measurement of how much value I'm adding to the software. It correlates like a little bit with how much I'm at my desk, but really at my desk I might be on Twitter, but in the shower I might be focusing and having this brilliant idea about what to do next. So I propose that instead we measure this in creplets. This is a real word. A creplet is a unit of time and attention. So when we're trying to put value into the software, it takes more than just time. It takes our focused attention. If I'm pairing with someone for 6 hours in a day with a lunch break, and we're coding that whole time, by the end of that, I'm done. I've got a couple more hours of time, but I'm done with focused attention. I got to go answer some emails or something that doesn't take my brain. We have limitations other than time in what we put into our software. So creplets. And of course, the other problem with this graph is the definition of value. What is value? Can we even say? We don't know how to define software value, and it constantly changes. That's why we need to be able to change what we're doing, not just how fast we're going, but the direction we're moving in. We need to be able to shift that as we learn more about what is value. So the thing about velocity is it's not the same as speed. Speed is how fast you're going. Velocity is how fast you're going in what direction. Velocity has magnitude and direction. So at any point, the velocity here is actually one upward toward happy, whatever that is. I had a physics professor in college who used to come to class dressed in a traffic cone and an orange cape to make the point that vectors have magnitude and direction. He did this for decades. I think he still does it. But it is a hard point to realize that velocity is not the same as speed. And that means acceleration is not the same as getting faster. Acceleration is change in direction or magnitude. The important part is to be able to switch what we're doing. Because if you come to me with a requirements change, I want to say, oh, we learned something about what the users want? They want this more? Okay, great. Now I can stop making the wrong stuff faster and faster. Because that doesn't help. And it's inherent in the system that the definition of value changes as we learn. So this is what I call a C-map, as opposed to a roadmap, because there is no straight path toward the goal. There is instead space that we can explore between us and where we want to get. So I represent where we want to get as this star. I shouldn't use the word goal because most people use that for something that can be achieved. And I'm specifically, this star is not something that we can achieve. An organization's mission should not be quantifiable, and it should not ever be a destination that you can reach, unless you really plan to dissolve your organization at that point. So for instance, your star, your quest, might be contribute to the systemic improvement of healthcare delivery and the health of communities, according to Cerner's website. So if that's your goal, FYI, implicit in that mission is while making money, because that's kind of like me saying, my goal today is to give this talk to you. Implicit in that is while breathing, because I want to stay around, right? For a company to stay around and be able to improve the state of healthcare, you need to also make money. But that's every company's goal. The one that distinguishes Cerner is about the improvement of healthcare delivery and health of communities. For me, for Atomis, the company where I work, we want to change the way development works by making it drastically easier for developers to automate their own work. Down here in the bottom right is this little boat. That's us. That represents a team. There's a couple people in the boat together. And between us and the star, we know we want to go in that direction where we think the star is. But we don't just head out straight for it across the ocean with a 3-year Gantt chart. That is a sure recipe to be eaten by sea monsters and drown. So instead, we look for safe harbors that are still in the general direction of where we think the star is. So we might visit this mountain first, and then stop and take our bearings. And so each feature is a small mountain. Each project is a bigger mountain. Each major release is a pretty big mountain. And we're all trying to go in the direction of the star, but we've got to stop in a safe place, which usually involves deploying to production, or at least a test environment, where we can take stock and re-navigate. because this direction is always going to shift. It is inherent in the system that this direction must shift. Okay, so now I'm going to draw the software system. These are the users. And this green stuff with the brown squigglies, this is your production application. And the blue squigglies, those are like queues. Maybe that's Kafka. I'm sorry, brown squigglies. But as your users interact with the software in order to do their jobs, collectively, they form a system. These are not independent of each other. There's one system here of the users and the software to help them do their jobs. And as they use it, people change, people learn. So if something is hard, they'll find a way around it. They'll either do it a lot less, or more likely, they'll find a workaround. So an example that came up at a user group a few weeks ago, if a nurse opens a patient record and gets 8 pop-ups that they must click through to actually get to the patient record, and 7 of those are routine, and 1 of them is important, how many is that nurse going to read? 0. Because what do you do when you get a confirmation box? You click, you get rid of it, X, okay, X. What we make difficult for people, they won't do, or they'll find a way around. Whereas if we had that information like somewhere contextually in the record where it made sense, maybe they would do it. It works the same way with making things easy. Making things easy changes the users. So if we make it super easy to see the possible conflicts between 2 drugs, or the interactions, and we put that contextually and they can hover over it and see it, they'll do it. But if it's 6 screens and a bunch of clicks and typing, then they're not going to do it. When we build software, it's kind of like changing physics. What happens when I push here? We get to decide. And so that changes people's world, and people learn, people adapt. So the users change as they use the software. Now, does the software change in response to the users? More slowly, I hope so, but only if there's some feedback from the users through support or whatever channels to us. We're over here in Neon. And then we can get that back to the software. For instance, a few days ago, there was this alarm in Hawaii. Everyone in Hawaii got a text message that there was a ballistic missile incoming and they should take shelter. That happened because someone clicked this instead of this. All right. I mean, you can, obviously, this is some pretty bad UI. And it took 38 minutes for the cancellation, the sorry false alarm text to go out, because this didn't exist. Which obviously, BMD false alarm is the thing to do after PAYCOM CDW state only. Does anybody think that in this software development system, this arrow existed? You know, who put that in front of people and then ask them, what do you think? Does this make your job easier or harder? It makes a big deal. Okay, so there's yet another reason that we need to be able to change direction. One is inherently the users change as our system changes, and so the system needs to change with them. The other is that as we're going along in this sea here, we might find, monster. So this boat, say in my current task, I'm retrieving failed build logs and putting them into a Slack snippet so that the person can receive a DM immediately. And say I hit a problem that it turns out on Travis CI, there are some API calls that require authorization and others that don't work if you do send it off. Apparently NPM is the same way. What the heck, people? Okay, that's a very easy monster to slay because I figured it out. Once I figured it out, it was easy. But so either when these monsters pop up and they're delaying us and preventing us from getting to that safe harbor, we either find their secret weakness, in this case it's don't send auth sometimes, and we slay them, or we're like, that harbor didn't look so good, I think I'm gonna just give them a link to the build log. we have those choices. So that pops up, and we have to decide whether to navigate around it. There's also surprises. There's always surprises in our technology. Like Travis is external, but even then, like I'm writing in TypeScript, and once in a while I get a weird compile error that what the heck does that even mean? And other times, I'm running on Node now, so there's plenty of surprises there. Oh, out of memory. How do I change that? I don't know. I know exactly what to do on the JVM, but I'm not so familiar with this boat. And then you get to the hard part. Okay, that's just technology. And someone on Stack Overflow, if you can just find the right search words, probably had this problem already. But let's talk about the business problem we're trying to solve, the feature we're trying to implement. It's easy enough to describe the happy path, but the happy path that the users are supposed to follow, even though that may be 99% of code executions, it is not 99% of the code. It's probably 10% of the code. Everything else we find as we go along, all these little error paths that we need to route people back onto the main road, or there's like little alternate routes that they may take that are valid to get to the top that we discover as we go along. If you fully specified in documentation everything that was needed to implement the program, that's pretty much equivalent to the program. It's as we code, as we go down to the ridiculous level of detail required by a computer to complete a task, that's when we discover this stuff. That's when we navigate the field of micro problems. And it is. I mean, our job is a discovery process of what all decisions do I need to make here, and then deeper and deeper. And it's tricky. And now I don't get so frustrated anymore at like that stupid Travis property, because I no longer feel like it's stopping me from doing my job. This is my job. My job is to find those infinite micro problems and defer as many of them as I can, and then solve the ones I need, solve the ones I have to. This is from the original software engineering conference, like when the word was first coined in 1968. Design until you feel you understand the problem. Write code until you realize you don't. Repeat. That is totally how it works. And to understand the problem, we need to know a lot. Sure, you need to know the technology, but more importantly than that, you need to understand the business. If I were hiring, I would look for developers who've worked in healthcare, if I'm a healthcare company, before I looked for developers who've worked in Java. One of these things is well documented on the internet. But more than that, even more valuable, as we go to map the tech onto the business space, we have to understand both of those. And what comes out of that is a system that is our own. And the existing system is drastically harder to get a handle on than either the tech or the business. There's a reason for that. Let's go look at what that's. There's several reasons for that. So before I hired developers in healthcare, I would try to retain the developers I have because nobody else has an understanding of the existing system, and that's the hardest to get. So going back to the existing system, let's look at our side of it. So our job is to manipulate, our job as these colorful people over here, is to manipulate this green software over there, right? To improve it, to increase its value to the more neutrally colored users. But we can't do that directly. We never manipulate software directly. It's not like we're walking over to the computer and handing in punch cards. And even if we were, the punch cards represent code. A running software process is kind of a different, more abstract thing. So we actually manipulate those programs with other programs. So this blue stuff over here represents the code that we use to manipulate the code, and also to generally coordinate and do our jobs. So if one of these is logging, then the production stuff is sending logs over here, and everything's sending logs. And one of these is deployment, and so it's doing this stuff. And we use some database migration process to change the database. We do none of this directly. The interesting bit is, we also don't interact with our tools directly, with the software that we use. So here's GitHub over here somewhere, and Splunk is over here. But again, they're running processes in a machine, and they're totally part of our system. Let's have a new color. This system that is us and our tools. But they're not something we can interact with directly. Instead, we have to pass through this line of representation. What we interact with directly is a mouse and a screen and a keyboard. We can read the screen. We can type on the keyboard. And for that, we have to have like screens in our tools. So Splunk is a great example of giving you vision into what's happening in production by providing a screen that you can access. And your deployment tool if you have a button somewhere. Or the fallback, SSH. You've got a screen, you've got a command line, you can type in. This is how we manipulate that software. For instance, here's Jenkins. Jenkins is a great example of one of the tools that we use in order to change software. People use Jenkins a lot because it's like, it has a UI and it can run commands on checked out code. So it gets turned into a lot of things. But in general, we have a lot of control over this blue stuff because it's not affecting our customers. Our customers do not have to be trained on it, only we do. And we can do a lot of ways of improving our work. So if Splunk, get this one, is one way that we observe what's going on, then we might have Jenkins or Travis or GitHub. I mean, when you push source code, that's a way that we communicate to the stuff in blue what should happen to the production software. And we have a lot of control over this blue system. The point being that like us and our tools and the production software that they manipulate form a socio-technical system. Our team members are not all people. Our team members are also code that we use, a lot of which we write ourselves. And that makes things interesting. That line of representation concept is from this Stella report, which I highly recommend. It's in the references at the end. But it points out how we learn about the system that we're working in. Because it turns out to be really hard to form a model of the software and how it works. And if we're going to change the software, if we're going to increase its value, we need to have some understanding of how it works so that we can reason about what effect this change will have. And there's a law, I forget whose law it is. In any sufficiently complex system, and we're all way past that point, everyone's mental model is incomplete and out of date. And for added fun, everyone's mental model is incomplete and out of date differently. In order to coordinate with each other, we need to have some similarity to our mental models. We use our blue tools to like help us form the logs, for instance, to give us an idea of what happened. And then we also have to talk to each other. And that introduces a coherence penalty as our teams grow larger, because we have to take a lot of time just to coordinate with each other to be sure we're sufficiently in agreement about what the heck is going on in the system to be able to change it in a way that doesn't step on each other's toes, so we can trust what each other does. That means we have a limitation to the size of team that can work together productively. So if we want to accelerate, if we want to do things faster, you can't just add people. Eventually, as anyone who's been in software development for 15 years has observed, adding people grinds everything to a halt. Best case, 10 people are doing nothing and 5 people are getting work done. Worst case, 15 people are doing nothing, or making it worse. So that coherence penalty comes out also at a time that with DevOps, and we have understood that as an industry, that software developers need to take broader responsibility for their code. Not just get it into source control, but care about what happens when it's in production. That's like a feedback loop that comes back to us from the software itself, probably through Splunk and alerting and paging duty, back to us so that we can learn, change our definition of value, and make better software next. But we can't add people. So how do we scale ourselves and broaden ourselves? And the answer is we make more stuff in blue. We move more activities below the line. Because if you're responsible for deployment and you have to understand the Linux operating system that the software runs on, and Travis and GCC or whatever the heck is involved in that, you just run out of headspace. We can't do it all. But if all of that is encapsulated in an automation, we push the button, we watch the logs and look for errors. That we can do. When an error happens, we can call an expert if we need to. Right, so I'm starting to see like why it's hard, because it is pretty inherently complicated. And then there's also the problem of whenever you add a new team a new person to the team, they have to develop a mental model of the system. And it turns out that's harder than you think it is. So here's another law by this Breitenberg guy. Downhill invention, uphill analysis. And this one says that it is heads and tails easier to write a complex piece of code than to understand someone else's code. Seriously, like if you've ever looked at the documentation to Redux and been like, oh my God, that's so complicated, I'm just gonna write my own thing. It'll be so simpler. Well, it will be easier. It won't be faster. It will take more work. And that little T will advance, and you'll feel productive, and you'll feel like you're doing something, but you're actually being lazy. So if you suffer from not invented here syndrome of I can do it better, no, you're probably wrong, because someone else has navigated that field of micro problems. And you're standing back from up in a tree and you don't have very good glasses, and you can't even see the individual blades of grass from up there. And you're like, looks simple. I'll just slide right on over there. You haven't figured it out. And if that library that you want to use doesn't do it quite like you want it, and you think, I'll just write my own framework for building CSS templates, yeah. Maybe the people who have spent years developing CSS templates have learned that that particular thing you want to do causes problems later. Maybe they're right, and you are just setting yourself up for pain. The other thing this means, besides read the documentation, just read it and spend some time getting to know the library and expect it to be hard because this is hard, is that any system you built, you have a special relationship with. You are its parent. You are on that downhill invention track, and you have a great mental model of the system because you wrote it. And someone new comes on the team, and you're like, it's simple. It just blah, 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 blah. It is not simple, okay? Never use that word with a new person. People don't realize how big an advantage it is to have been around since the system began, to have been part of a lot of those sea monsters that came up, to have the history of why it looks like it does, because figuring it out, especially if you have to go down to the code, is wicked hard. And you don't know how much you know. So this new person comes along with all these questions, and you don't even realize how much background you have, because you're on that downhill slope, and they're trying to do the uphill slope. Oh, and the worst is when it's like a system that one person has written, and they're still working on it, and I'm trying to contribute. I'm trying to get a grasp. I'm trying to build my own model of this system, but they can change it faster than I can get a grasp, and it is impossible for me to ever catch up because it's moving, and it's in their heads, and I can't get it in mine. Pairing is the only thing I've ever found that helps with that. So appreciate that, because if you gave birth to this system that is now moving out into the world, then you know all its weird little family pronunciations, and you know all its inside jokes, and you think they're funny, and other people are just confused. So if you are that person, please be kind to others. And if you're this new person on the team, it's not you. You're not stupid. This is really, really hard. And it is harder than writing it. So don't let that other person feel superior. Or let them if it causes them to answer your questions. But it's not you. Because our software, I like to think about starting off software, and the first question to answer when I'm going to write something, when I'm going to implement a feature or something is it useful? Or maybe it's a program that I'm writing for myself, like one of those blue tools. which you can totally experiment with because they're really only going to annoy you if they don't work. It starts off as a baby. Maybe it's a program on my computer, and that's fine. I'm raising it, and it's just a simple script, and whenever it errors out, I change its diaper, and that's okay. And eventually, like, I want to share it with my team, so maybe I deploy it as a service. It becomes a toddler. And if that becomes useful to our team, maybe we want to release it to the whole org. And then we've got to, like, think about, like, authentication and how do we make it available to people. And then if we actually release it into the world, it has a chance of, it becomes a teenager, right, with all its angst. And then we find out about the real errors that happen. And you can't mature past this without real-world content or real-world contact. And as we start adding handling for each of those errors, remember, it's not a bug if it's not bugging anyone, then the software grows up. And we gradually add maturity to it until eventually, maybe, if it's really, really, really useful, we might put enough energy to make it an adult. Take care of yourself. Call me when something really weird happens. But more likely, somewhere in this life cycle, if we ever stop, say we leave the company, but our little toy software is still running and people are using it, but nobody's developing on it, and so pretty soon its libraries are out of date, and nobody can get it to build anymore, and then we have, I think that's a zombie potato. Yeah, we'll go with that. Anyway, then it becomes zombie software, and it will eventually eat your face. So software, to be alive, it needs to be part of that socio-technical system with a person, because it's we who can change it and grow with it, and then it can help our team, and our team can help it, but it's got to be alive like that. There's a reason that, this is one of the reasons that I think that software maintenance is not a very good term, because maintenance implies we know what it needs and it needs it on a regular schedule. And that's not true. We don't know what it needs. Everything we do to our code, every change we make is a new change that we've never made before. We don't grease the same kitchen cabinets all the time. So I propose that instead of software maintenance, we call it software parenting, because it's different every time. Every piece of software is its own thing to take care of. Every legacy deployment, it's its own baby. And then the question becomes, I mean, how do we continue parenting software while still giving birth to more and adding value? As an example, real quick, a couple months ago, we decided, oh, I think we should expose our data behind GraphQL. Yeah, I wonder if that'll work. So to find out whether it's useful, I did the simplest possible thing. I downloaded the Neo4j extension that supports GraphQL, and I made this little schema, and I pushed it up there to production manually. And then I got annoyed by having to make changes to it, so I wrote some scripts that I could run to push that up manually. And eventually it was like, yes, okay, this is useful. Yes, we're going to go farther in this direction. This is adding value. So I upgraded it to a toddler by wrapping this script in some TypeScript code and pushing it up as an Atomist automation so that anyone on our team can deploy it from Slack. So they don't have to create, seriously, it was 2 different accounts in our Neo4j database, and there was some other authentication thing that you had to, like, jump through these hoops to get set up in order to push the schema up to staging our production database. So I just put my creds in the service, and then it's fine. Anyone who has access to our Slack can push the button, and it pulls the schema out of GitHub and pushes it to the appropriate database staging or production. So that was great. Since then, our Neo4j support has begun to enter the teenage phase as we have like a service and we're starting to do our own authentication and stuff like that. Meanwhile, we helped evolve the Neo4j extension that supports GraphQL because it's in the early teens, and so we were able to provide, hey, I got this error. Hey, I tried to do this. Hey, aren't you supposed to be able to do this? And they were like, thank you so much. That's wonderful. Now we have more information about the definition of value, and they changed their code and matured it a little further. This whole software parenting analogy totally explains the definition of what is done. Because when are you done parenting? Never. Hopefully never. And when are you done with a piece of software? When it is out of production. When no customer, or at least no customer with a support contract, is using it. This means all those features that aren't useful, the more features you can take out, the better. The smaller mental model people have to acquire in order to change the software. And that is our limitation as individual developers, is how much can we hold in our head and how much can we get loaded. The problem with all this existing software, the babies and the toddlers out there, is that there's overhead to keeping them running. And so this jar represents all our creplets for the day, all of our units of time and attention. And a certain amount of those are consumed by overhead, of just stuff we need to do to keep existing stuff running, or status reports that we need to give to someone outside our team, and they're getting in the way of what we want, which is our forward velocity. So what we hope is that we can spend some time on acceleration, on working on, might be automating our own work. Usually it's reducing this overhead, because the thing about the overhead is, man, if there's a production outage that takes up this much time, or if I've just got to take my kid to the dentist, that overhead is still there. So there's only so much work you can get done, and it gets eaten away really, really fast when most of it is overhead. It's really hard to make forward progress. So we have to work on reducing that. To reduce that, we need to grow our programs up, mature them so they can take care of themselves. I measure programs on the scale of shell script on my computer to Netflix. Now, Netflix, you're talking about some major, major serious adulting there. And that is like hundreds of thousands, if not millions of times more effort than that shell script. Like really, 6 orders of magnitude. Most software never needs to get there, to that level of uptime and availability and stuff. One thing, but the goal is to be able to mature it gradually as it proves itself useful. Netflix has proven itself useful. They make enough money that it has been worth adulting their software and giving it all those magic microservice properties. Most of us don't need all of those. However, if you're going to focus on some, come on, go down. Focus on these early ones. Versioning, testing, and deployment, because these enable change. And if you can change it, then you can add everything else later. You can add auto-scaling, you can add in observability and logging and monitoring, tracing, and everything that you come to need, all the bugs that start bugging you, you can fix if you have good tests and you can deploy without worrying about it, and you have careful versioning, so if you do need backwards compatibility, that's mostly in a library case, you can do it. Because our job is not to write software, it's to change software. Yes, this involves writing some code, but really that's the least of it. Getting a system from one state to another is really hard. Those database migrations, core to our job. They're not a side activity. They're not a distraction. Our job is to move a software system from one state to another. And that writing code is only a piece of that. So we want our software to be adults so that we can go have more babies and write more fun things. One interesting point is that a lot of these things that move a piece of software from baby to adult aren't actually in the software. So your tests are separate from your source code. Backwards compatibility might be in the software, or it might be in a proxy outside of it. Recovery, you can add on as a separate process. Alerting can be something else that's watching, a babysitter process of some sort. Out-of-date libraries, we can automate that. I mean, we do that at Atomist. We run a program to say, make a pull request for everybody that needs this library upgraded. Clone all the repos, find the ones that are offending us, and pull request, and then we can click merge. So interestingly, a lot of this stuff winds up in the blue part in this socio-technical system that is us and our tooling, and we control that. Now this system in particular, we learn from our software. We learn about how the system works, and that changes us. So we are a changing piece of the system. And also because we are developers and we have the superpower, we can directly change the code that we're running in our tooling. So software development is a special case of work. Nurses probably can't change the software that they're using every day, but we can. We control the physics of our own world. And that's pretty amazing. And I think we should do more of it. Because when we do that, this system forms a symathecy. And this is a word that I learned from Nora Bateson. Sym is from the Latin for together, and mathesy, learning. So it is a system of mutual learning. And together with our environment, which we control, even if it's just, your personal shell scripts, you control how your world works, and you can invest in that. So I'm a big fan of automation, particularly automation that we do for ourselves, because then it can stay in the baby phase or the toddler phase if we just want to share it with our team. And that is so cheap compared to adult software. So automation, people think that you would do it to save time. That is the least of it. Take my favorite tiny example is I have a script that I wrote to make a pull request. So if I check out a repo and maybe I just changed an error message or updated a comment or fixed a typo somewhere, it seems too small to make a pull request, but I really should make a pull request. And I do now because I've made this tiny script because I got tired of typing 3 things and then opening GitHub. And the script just make a commit, check out the branch, make a commit, push the branch to GitHub, open the web page that shows me that branch so I can push, create pull request. And it's a tiny thing. Does it save me time? No, it saves me 3 seconds of typing those 4 things. What it saves me is couplets, because each of those things is a piece of attention. And my attention is limited, not just my time. And even more importantly, because now it's so easy, I do make pull requests for my typos, it's changed my behavior. I mean, it's a small thing, it changed my behavior in a small way, but this is the real power of automation. It doesn't just save time, it saves couplets. And it changes behavior. Other things that are useful, especially for selling it to management, safety. I don't mistype things. I don't accidentally commit to master, tiny things. Another one, favorite example is project creation. So if you're building a web app, for instance, and you need a new endpoint, do you spin up a new service or do you glom it onto an existing one? Well, if spinning up a new service and setting up CI and the tests and the deployment and getting it machine to run on in production, if that takes a week, as it did at my previous job, then no, I'm just going to glom it onto something else. But if I spend the time to automate spinning up a new project, and that goes from a week to half an hour, then yeah, I'm going to spin up a new project. And that's a behavior change, which results in better architecture, because now these my endpoint and whatever else I was about to glom it on are not coupled. The mental model is smaller there. If my endpoint turns out to be not useful, I can delete it faster, which is excellent. And if you are the person, say as an architect or a dev lead type, who writes that project creation automation, everybody's going to use it just because it's easy. And you control what new projects look like. Do you want Spring Boot? Do you want a slight variation on Spring Boot with a few things that are specific to this organization? Make it yourself. And then, as every error that occurs, like in my pull request, it's like, oh, the branch already exists. Okay, I'll add error handling for that. And I add the error handling once, and then that bug never happens again. So I wind up dealing with problems once because I've documented how to deal with it in my automation. Reproducibility is great for accountability. How do you do deployments? We run this program because the only real documentation is code, and your automation documents your process better than a README. Oh, I have one friend who does README-driven development. He'll start out writing a README on, say, how to set up your development environment. And if he goes into enough detail to make it actually useful, it gets sufficiently painful that it's like, oh, I'll just write a script. And then you wind up with something reproducible and safer than doing it yourself. And this last one, this is really all about management. Legibility is a word that means understanding that rolls up. So I actually got this word from a book, Seeing Like a State by James C. Scott, which is about city planning and forestry and government kind of things. And it comes from, in the Middle Ages, people went into villages and said, everyone has to have a first and last name, and your streets have to have names, and your houses have to have numbers. And people were like, why? We don't need that. Everybody knows everybody. And we just have nicknames, and it's fine. But the reason was they wanted to tax, as empires got bigger. So it wasn't sufficiently legible from a high level when there were just nicknames and property was fuzzy. This is mine in the winter, but he uses it in the summer kind of thing. So they went in there and they put lines on everybody and gave everybody a first and last name so that they could count the population, because if you have a list of people, then you can count the people, and counting is a monoid, so they can add the different counts from different cities together and into regions and countries, and they could track changes in population. And yeah, it's a way to understand something about the kingdom that rolls up small to large. Now, in your automations, if you're the one writing the automation and you want a big picture of how your projects are doing, well, one thing you could do is, if you have the organizational power, you could decree that everyone will follow exactly these steps in JIRA when they have made the final commit that represents the feature and they think it should move on to the testing phase, or whatever it is. Or you could make an automation that comes up when they've made a commit and said, are you done? They click yes, it reports it exactly where you want it. And then nobody has to go to JIRA. You get exactly what you want in JIRA. Everybody's happy. So for me, and I've got some automations that run TS-lint on every commit, for instance, and those automations also happen to report to me in a channel every time someone made a commit and whether they had any linting errors. So you can spy with them. So one of the reasons people give for not doing automation of their own work is that it's not our job. We're trying to get to that star up there. What does this have to do with it? Well, it gets back to the breathing thing. You do need to scrape the barnacles off your boat, and you do need to grease your oars, and you need to upgrade to the latest electric oars if you want to go faster than the boats at the competition. But you have to watch that. The thing you have to watch is measuring productivity. Measuring individual productivity will kill your organization. People find ways around this, but in the principles of flow, there's 4 principles, most of which I'm not going to talk about, but number 3 is abolish local efficiencies. If you measure individual productivity in terms of stories cards completed, and that's what people are judged by, then that's what people are going to do. They're not going to make their job faster. They're not going to help their teammates. They're not going to answer the questions. They're going to do what you're measuring them on. So I think we need to stop measuring that at an individual level, because our objective is not to personally produce story points. Our objective is to get the whole boat. It's not just about my oar going faster. It's about the whole boat getting to the next harbor and all of us being able to take stock and look around again. So instead of productivity, I think we should evaluate ourselves on generativity. Generativity is not what I personally produce. It is the team's output with me versus without me. So every time I help someone else get a better mental model of the system, that's generative. That's helping the team. If I make an automation, it might just help me, for my net output, but then if I share it with my team, it can help them. And if I expand that to the larger organization, I can be much more generative than I could ever be productive. Another thing to watch out for is that if the new person on the team, or the person who's a minority on the team, or the person who in any way doesn't feel certain that the rest of the team has their back and has confidence that they're good, those are the people who are going to be like, heads down, I got to get these story points out. And that's very, very rational. So if you value generativity over productivity, then you help bring everyone on your team up, especially the people on your team who have it rough. So this can be like measure the team output, not the individual, and say thank you to everyone who helps you and answer people's questions. Oh my gosh, it's so much more helpful than just getting that next thing done. Now, of course, there is a limit. We shouldn't spend all of our time automating. So how much time should you spend automating? And I think the answer is to time box it. The time box, make a square time, yeah, that one will do. The time box is kind of the magic. How much time should I spend on it depends on how useful it is. So the first time I get annoyed at it taking 4 commands to type a pull request, I just type it. And the second time, I just type it. And the third time, maybe I spend 10 minutes scripting it. Because I've learned that it's going to be a little useful. And then if that's not enough, in this case it was, but if that's not enough, then maybe the 4th or 5th time I give it an hour. Or I talk to my teammates, does this bug you? Oh wow, this bugs all of us. I think it's worth giving it half a day. And then after I started using that script like all the time, then it was worth adding like check whether the branch exists. Oh, maybe I've already made the commit, handle that case kind of stuff. So spend only as much time on it as you're sure it's going to be useful. And remember to measure that usefulness in creplets. So your frustration, your experience matters. Okay. The goal being that we need to reduce the amount of overhead that we're spending. Oh, where'd that brown go? Over time, we want less overhead so we can have more velocity and then keep working on acceleration to further reduce overhead because it's a continual process because you're always making software that needs to be matured. To get better at our job, we have to get better at doing things we've never done before. And there's a whole book on transfer of learning, which transfer of learning is taking stuff you've applied in one place and using it somewhere else. Which is exactly what we need when we're doing new things all the time. We can't just use the same skills. We have to be able to move our skills. So I don't actually recommend this book. It's expensive and not very fun to read. But here's what it says that you need to know. You need at least these things to be able to transfer your learning effectively. One is expertise. And in particular, you'll want to be really good at one thing. So go deep on some language. And give me this. Oh, yeah, okay, just give me that. All right. And then make sure that's filled in, you know, when not to use it. And then know a little bit about a lot of things. My grandmother always used to say, know just enough to have a conversation about 1,000 different things, because then you get more conversations. It's great. Your mood is affected, so when you feel interested in something and have a practical aim is the best time to learn more about it. When you have a business question and that you need to solve a problem in your program and you track down that business user, go a little deeper. Ask them why it's this way. Get a little more breadth of information because now you have the practical aim and the feeling of interest that helps you hang it in a framework and remember it and apply it in other places. Reflective practice, you do not need 10,000 hours. 20 goes a long way, but do like practice and then reflect. Theoretical knowledge, yeah, learn your data structures. It helps you learn what was an accident and what is going to transfer. And culture of transfer, I'm hoping to get to in a minute. I'm going to skip levels of transfer because I'm almost out of time. But we need that really deep business and system knowledge because what we do in our job is not mostly writing code, it's mostly making decisions. These are my attempts to draw fractals. And the point being, as we get further and further down into that field of micro problems, every one, we have to make at least one decision. Do I handle this null error? Nah, it won't bother me. Actually, yes, please do handle that one. Because that's like stepping on a Lego when I get a null pointer exception. I hate it. But what do I do with it when I have it? Do I log it? What do I say in the log? Every one of these is a micro decision. Our job is not writing code, it's making decisions and recording them in code. This is why you can't outsource software development effectively, because you have to have enough understanding of why you're writing this at all to make those micro decisions in a reasonable fashion, or else your software it doesn't make sense when it comes out. We've got to at least be able to make a good guess and have a good guess at which things need to be elevated to someone else. So I don't want to write fewer lines of code. Whoop. Ooh, you can almost see it. I want to make fewer and easier decisions. And to do that, I need the expertise in the business. These are my creplets. Every decision is a creplet. So automation can help. Shout out to code formatters, because consistency is useful, but I don't want to make a decision about how many spaces or which line this curly brace is on. Please make a program do that for me. Anything that you can outsource is fantastic. So like we use hosted Kafka and hosted Neo, and anything you don't have to understand every problem it could possibly have in order to debug it when it goes down in production, great, someone else can do that. Expertise helps us make these decisions in the tech and the business, and most of all, in the system. But in that order, like the business is the first, and the tech I can look up on Stack Overflow, which brings us to which programming language is the best. So these are some programming languages that I have either used at work or given a conference talk about. And I think I have enough qualifications to say that the best one is definitely whichever one you already know. Because you can learn a new language in a week or two. You can learn the syntax. But you can learn the idioms and the libraries and the community and the deployment tools and the build tools and the dependency management, oh my gosh, and the runtime and the memory management in decades. So yeah, go deep on something, and then if you need to use something else occasionally, fine, but man, I am happy to concentrate on one language now. That is, at our local polyglot meetup group, they're like, what's your programming language for the programming language goal for the year? And I was like, to not learn a new one. That would be so different. I would be so powerful if I actually got to be good at something again. And major shout out to tests, because tests give us safety for change. Tests do more than just let our software work. They show that it works. And showing that it works is way, way harder than making it work. Beyond, oh, I feel that it worked on my machine. And tests show that it continues to work under change, which we desperately need. So tests are freedom. Because we're not writing systems. We're moving systems. We're not working in a vacuum. We're not all playing with greenfield toys. The only time I ever write a system is for my own entertainment on the weekend. I am moving systems. And that means I need some deep understanding. And I'm already late, so I don't have time for cultures of transfer. But yes, this is hard. It really is hard. We're changing a system that is part of a system that we are part of, that in turn is part of, like, this thing down here is supposed to be all of technology, and this green stuff is the economy. And it's all changing all the time. So yeah, we can't predict the effects. But if a lot of people have said that growth is a series of I'm not who I thought I was. Yeah, so maybe my job is not being productive, writing code, making it work, and building systems. Maybe, give me the pen, my job is, in fact, ooh, that's not a good color. That's also a bad color, but oh well. Maybe it's being generative, making decisions, showing that the code works, and moving systems. And when I think of it this way, I can accept that it's hard, but I'm not a failure for struggling with it. This struggle is my job, not the lack of it. So yeah, keep your eye on the star. It's okay that you'll never reach it. Those are the best kind of stars. Automate your oars, keep your heads up from navigation, and work together with your team. The end.